STA 3624 Time Series Analysis and Forecasting. Lesson 7 Estimation and Elimination of Trend in the Absence of Seasonality. You know that there are two models, that is additive model and multiplicative model. Additive model we can write YT equals TRT plus SNT plus IRT plus CLT. These are the four components we already knew. This is trend, this is seasonality, this is irregular fluctuations, and this is cyclic variation. Multiplicative model also you can write by multiplying all of these components. In the absence of the seasonality we can write the model, then we can write this is the addition of or multiplication of two trend and irregular components. And to remove the trend we can use two methods. One is the smoothing method, other one is the Box-Jenkins method. This can be done by using the computer software. There are four steps. Those steps are identification, estimate parameters, diagnostic, checking, and forecasting. So by using these two methods we can remove the trend. So we are going to consider about the smoothing methods. Smoothing refers to a particular type of moving average technique to apply to the time series data, either to produce smooth data or for presentation or to make forecast. So you know that we already discussed about the moving average. So here moving averages, how to find the moving averages. So in here also there are we are going to calculate some moving averages and any other methods also, so that we can use for the smoothing. So we will discuss one by one. First one is the smoothing with the simple moving average filter. The simplest way to smooth the time series is the method of simple moving average process. The smooth statistic, that is ST, is just as the average of the last k observations. So as an example, if you take 3-year moving averages as we discussed in the previous lesson, so how we can do is we have to add last 3 observations, then divide by 3. In here if we take k observations, what you have to do, you have to add last k observations and divide by k, right? If so then where the choice of an integer k greater than 1 is arbitrary. So here for finding at least we need 2 observations to find the moving averages. And the smaller values of k will have the less of a smoothing effect and be more responsive to recent changes in the data. Larger k will have a greater smoothing effect and produce more pronounced lag in the smooth sequence, right? So if you so you can use k for then sometimes smaller values and sometimes larger values. That is up to you and according to the nature of the given problem. And the disadvantages are given equal weights to all of data is not suitable. It is reasonable to give more weights to most recent data and less weights for the older data. Cannot be used of the first k minus 1 terms of the time series. You know that when you find a moving averages, so we can't use that first k minus 1 terms in the time series. It means that if you need to find 4 year or 4 month moving average, what you have to do is first 3 terms we have to omit. Why is that? Because we have to add the all 4 terms, first 4 terms, and divide by 4, and we can write that is in front of fourth term. It means we omit first all 3 terms, right? So that's why that is then disadvantages and also disadvantage. And also then if you consider about that weights equal weights are given, but then if we have to give more weights for the recent data. So now to overcome this problem we can use weighted moving average filter. So then second way is smooth with the weighted moving average filter. A slightly more integrate method for smoothing a raw time series is to calculate a weighted moving averages first, choosing a set of weighting factors w1 to wk such that sigma n equals k, w1 equals to 1, and then using the weights the smooth statistics ST can be calculated. So then here you can find ST equals wn times t plus 1 n, t plus 1 minus n. So this is the way of finding weighted moving averages. So what you have to do is you have to multiply by corresponding weight with the observation and add all together, right? In practice, the weighting factors are often chosen to give more weights to the most recent terms in the time series and less weight for the older data. That is for overcoming that, for the disadvantage which is in the moving average filter. Now if we take the weighted moving averages average filter, so we can use the more weights for the recent one and less weight for the older data. This technique is also has some disadvantage as the simple moving average technique, that is, it cannot be used until at least k observations have been made. So here also we can't use at least k for the k observations had been made for this weighted moving average filter also. Then third one is exponential smoothing. This is the most I think we are considering more about that exponential smoothing because we are doing some calculations by using this exponential smoothing. So exponential smoothing is a very popular type of moving average technique applied to a time series data. It is commonly applied to the financial market and economic data, but it is can effective with data from other areas as well. It is more effective when the parameters describing the time series may be changing slowly over time. Exponential smoothing assigns the exponentially decreasing weight as observation get older. Recent observation given relatively more weights in forecasting than the old observations, as we did in the weighted moving average filter. Exponential smoothing can be applied to model time series that have no trend, with trend, and with series exhibiting seasonal variation. So in that, if we know trend, simple exponential smoothing you can use. With trend you can use a double exponential smoothing, and if you have with series exhibiting seasonal variations, what you have to do is you have to use the triple exponential smoothing. Then simple exponential smoothing for a series xt, and output of exponential smoothing algorithm is commonly written as ST. Such may be regarded as the best estimate of what the next value of x will be. When the sequence of observations begin at time t equals 0, then simplest form of exponential smoothing is given by this formula. Formula is equals, so if you are taking always s0, first one is equals to x0, and second one you can use by using this formula, that is alpha times xt plus 1 minus alpha times st minus 1. Alpha is given in the questions, right? So and you can do the simply you can remove the brackets, then you can take this one st minus 1 minus alpha st minus 1, and you can take alpha out from the brackets. Then you can write modify this equation like this way: st equals st minus 1 plus alpha times xt subtraction st minus 1. This is forecast error. So where alpha is the most smoothing factor, it is given in the problem, and it is in between 0 and plus 1, and value of alpha is close to 1, it has a less smoothing effect. Value of alpha is close to 0, then it have a greater smoothing effect. Initial estimate for the S0, sometimes it is S1 if t start from 1, right? S0 S1 if it is t start from 0, that is S0. If t start from 1, that is S1, right? The initial estimate for the S0 or S1 may be taken as the first observation. As we discussed in there, it is taken as first observation always. And however, when the long series is available, it is possible to use the average of the first few observations. If there are long series is available, so you have to use the initial estimate as average of first few terms. And this example, consider the following data set consisting of 12 observations taken over time. By choosing alpha equals 0.1, do simple exponential smoothing procedure for the data set. So you can use this formula to do the exponential smoothing, right? We can use this one. So here given alpha is equals 0.1, so what you have to do is then st equals st minus 1 sorry, we can substitute from there. ST equals 0.1 times XT, 1 minus 0.1 means 0.9 times ST minus 1. So yeah, so you know that initial estimate always equals to x1, so that is equals to first observation, that is 71, and alpha is equals to 0.9, so you see 0.1, so you can substitute 0.1 from here. Then 1 minus 0.91 means 0.9 times s1, st minus 1 means s1, no, s1 is equals to 71, so you can substitute 71 from there. Then you can take s2 as 70.9. s1 is the initial guess, s1 is 71, then that's how we can take s2 as 71 by using this formula. Then you can find s3. Now s3 equals 0.1 times x3 plus 0.9 times s2, st minus 1 means here s3, no, then s2 you have to take, so then you can substitute the values. x3 is 69 and 0.9 times first previously find value is for the s2 is 70.9, so you can substitute from here. Likewise you can substitute for the given you can find that s up to s12 by substituting these things, and you can fill this table. So then these are the forecasting values, right? These are the values, so you can find. Then forecast error means xt minus st minus 1. So xt is here 70, then st minus 1 means this one, 70 minus 1, that is minus 1. So then here xt is 69 minus 70.9, that is 1 minus 1.9. Likewise you can find the forecast error also. Okay, I think now you know that how you can do the exponential smoothing. That is not a very complex one, just you have to substitute the formula, and you can find the estimate the smooth value. Then forecast error, that is xt subtraction st minus 1. I explained how you can find the forecast error. And forecasting with the simple exponential smoothing. Say we want to forecast from the same origin. Usually the last data point is xt to some several time steps ahead into the future. Modified formula, we can write st plus t equals alpha x origin plus 1 minus alpha st plus t minus 1. That is the forecast value, right? So where the x origin remains the constant, this x origin is always remains the constant, so then you can find the forecast using this modified formula. So we can consider an example. Assume that the last observed data point of the above series is 70. It means t12 is equals to 70, and the forecast value st minus 1 is equals to 71.69. but forecast further we do not have any observation xt from t equals 13 to 14 likewise. So therefore we can take x origin as the value 70 and do the calculations by using the following formula, that is the formula we discussed earlier, right? So then when t equals 13, if t equals 13, what you have, that's the first value, no, then what t, this capital T equals 0, right? So then then you can use this formula. Then alpha is given that is taken as 0.1, and x origin is value is given, that is 70, x origin 70, and 1 minus alpha is 0.1. then here st minus 1 plus t minus 1 means 12 plus t means 0, then sorry, here t equals 13, no, then s12, yes, that is s12. So you have to take st minus 1 plus 2 s12. You can take from using this table. S12 is equal 71.5, right? Sorry, it is given in, that is a separate question. It is given in here. st minus 1 forecast value, st minus 1 is given as 71.69, so you have to substitute 71.69 for 67 for here, right? Then you can find this one. Then if you need to find s14, what you have to do is, origin is not changing, that is 70, Then here now here t plus t minus 1 plus t. If t equals 14, then what? T minus 1 is 13. 13 plus 1, right? So then t equals 1 now. Then S13 is, now you know that S13 is 71.5 we found. Then you can substitute here. Likewise, and then here S14 we found, S14 is 71.75. Likewise, you can find the other values also, right? Then last method is differencing method. Differencing method is special type of the filtering method to remove trend. It is a trend in the series. The differencing procedure is carried out in order to obtain a series which exhibit no trend. If there is no seasonal variation, it is enough to get first difference. First order differencing is widely used in business and economical data. So difference of observation, so we discussed this in previous lesson also. Then we know that the difference of xt is we can write xt minus 1, and st minus 1 we can write using the b operator, that is b times xt. Then we can take xt out from the bracket, then 1 minus b times xt. If you take square of difference xt, what you have to do is difference of difference xt, right? So we found this part equals 1 minus b times xt. So then next you have to do is this difference here again you can write this way, 1 minus b times xt. So 1 minus b times difference of xt, that is 1 minus b times xt. It means 1 minus b squared times xt, right? I think you got the idea. Anyhow, I write and show you. This is again you can write 1 minus b times xt. Then what happened? This 1 minus b and this 1 minus b multiplied, right? Then it's come 1 minus b squared times xt, right? Then you can remove the brackets, so you can square this. Then 1 minus 2b plus b squared times xt. Then you can remove the brackets. Xt is coming here, 1 minus 2b xt b squared xt. So then you can again remove the b operators. This is xt. Then this one b1 is there, it means t minus 1 here, x t minus 2, right? So this formula we discussed in lesson, I think 3 or 4, right? I think lesson 3. So this is again we can follow this procedure, and you know that fbj xt is equals xt minus j. So if you find the difference of difference j times, that means 1 minus b to the power j times xt. This is the formula, right? Linear trend operator, mt is given as c0 plus c1t. Then if you need to find the difference, then difference of mt equals mt subtraction mt minus 1. But mt is given c0 plus c1t, then mt minus 1 means c0 plus c1 times t minus 1 is there. So then you can remove the brackets, c0 plus c1t subtraction c0, then subtraction c1 plus c1t. So then you can find the c1 is here, then thus difference of mt is c1, that is the constant function, right? So then if you need to find difference 3 times of x5, so you can use this formula and you can find it, right? You know that this is simple simplification. So I think you know that how you can do the smoothing one. So mainly consider about the moving average filter, weighted moving average filter, and the exponential smoothing to smoothing the data. So then that is the last lesson of time series analysis and forecasting. So then I think now you have already finished all the lessons, and based on this lesson also you have to do an assignment, and after that now our course is finished. I think we can discuss, if you have some problems we can discuss further, and then we can conduct our examination. So then wish you all the best with your examination, and thank you very much. If you have any problems, you can let me know. Thank you.